Hi everyone! For this video, we're going to discuss the limit of logarithmic functions, which is the opposite of the limit of exponential function. So we have the limit as x approaches a of logarithm of b or g, logarithm of g of x base b is equal to the logarithm of g of a base b. So we just substitute our x values to our function, and it goes the same with our natural logarithm. So the limit of natural logarithm of, or ln g of x as x approaches a is equal to ln of g of a. But you have to take note that our g of a should be greater than 0. Okay, let's solve some examples. But before we solve some example problems of limits of logarithmic functions, as I mentioned earlier, logarithmic function is the opposite or the inverse of exponential functions. So let's recall that concept. So for example, we have the logarithm of a base b is equal to c. So if we will convert to or rewrite this into exponential function, so we still use the same base b, but then the exponent instead of a will be c, and that will be equal to a. So we just switch a and c when it comes to logarithmic to exponential or vice versa. So let's say, for example, we have 3 squared, okay, is equal to 9, right? So 3 squared is equal to 9. We're writing this using logarithm function. So we'll have the logarithm of 9. The base is 3. So we use 3. And this is equal to 2. Okay? So remember this topic? Alright, so let's proceed now to limits of logarithmic functions. Evaluate the limit of the logarithm of x plus 80 base 3 as x approaches 1. So by direct substitution, so this will be equal to f of 1. So let's substitute our x with 1. So it's the logarithm of 1 plus 80 base 3. Okay. So this will be the logarithm of 81 base 3. So in other words, we can rewrite this using exponential function. Base 3, what would be the exponent, all right, to give the answer 81? Okay. So 3 raised to x, and 81 is 3 raised to the 4th power. So therefore, x is equal to 4. So in this case, the answer, logarithm of 8 base 3 is equal to 4. Evaluate the limit of the logarithm of 2x minus 5 base 2 as x approaches 3. So let's use direct substitution. So this would be f of 3. And replace our values of x with 3. So this would be the logarithm of 2 times 3 minus 5 base 2. So the logarithm of 2 times 3 is 6 minus 5 base 2. So the logarithm of 6 minus 5 is 1 base 2. So we're writing this to exponential form, exponential function. What is the exponent of base 2 to give an answer of 1. And we know that it is 0. So therefore, the answer for this is 0. Okay, next. Let's try this example. Evaluate the limit of the logarithm of 5x plus 2 over 10x plus 12 plus 6 as x approaches negative 1/5. So if the base is not given, we know that the base is 10. Okay, so by substitution, so we just need to substitute our x values with negative 1/5. Okay, so f of negative 1/5 is equal to the logarithm of 5 times negative 1/5 plus 2 all over 10 times negative 1/5 plus 12 plus 6. Simplifying, we'll get the logarithm of 1 over 10 plus 6. So use your calculator to find the logarithm of 1 over 10 plus 6, and that will give you an answer of 5. Let's try this one. The limit of logarithm of x squared minus 8x minus 1 base 2 as x approaches negative 5. So by direct substitution, all our x will be replaced by negative 5. So this is f of negative 5, so equal to the logarithm of negative 5 squared minus 8 times negative 5 minus 1 base 2. So this is equal to negative 5 squared is 25, negative 8 times negative 5 is positive 40 minus 1 base 2. So this is the logarithm of 25 plus 40 minus 1 is 64 base 2. So again, to write this into exponential form, what is the exponent of base 2 to give us 64? So what is 64 in exponential form? That is 2 raised to the 6th power. So therefore, x is equal to 6. So the answer for this limit, as x approaches negative 5, is equal to 6. Let's have a natural logarithm example. So evaluate the limit of ln of 2x plus 5 plus 4 as x approaches negative 1. So we use direct substitution. So this would be f of negative 1. Okay. So f of negative 1 is equal to the ln of 2 times negative 1 plus 5 plus 4. So that is ln of 2 times negative 1 is negative 2 plus 5 is ln 3 plus 4. Okay, and then use your calculator to find ln of 3. So ln of 3, do that with your calculator. After you get that, you add 4. So the answer that you will get should be 5.0986. Okay. Alright, so that would be all for today. Our next video would be about the limits of trigonometric functions. See you!